Welcome to a new test and teardown video. This time it is homebrew. And I believe this is nixie tubes. So I also would guess this is a nixie clock. And there's no screws in this, so it's real easy to take apart. I got this real cheap at a flea market. And he said, well, I think it's not working. But look at the mechanics. This is absolutely beautifully made. So that's actually one of the reasons why I got this. The case is quite nice. It's possible to clean this up. Ooh, this is not good, huh? Look at that. See? There's a screw missing here, so all I have to do is... Oy, 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 this can't be good. Oy, oy, oy. What do you call this? But the fun thing is that somebody cleaned off some of the dirt and then mounted this. Aha, so this is how the case is assembled. Right? So there is just this one screw that go all the way through, and then there's a hole. Yes, that is how it works. Here is that screw. But definitely something exploded inside this case. Oh no, so where is it? This capacitor looks very burned on that side, and then somebody just cleaned this off. So this was cleaned up, and then maybe it was the previous capacitor here that was exploding, causing all this. But I can see also here it didn't clean up. So it was repaired. But how do you think about that? This case, the front here is beautiful in the way this case is made, right? And then we got those copper bars soldered. The PCB is soldered to this, right? So I can't take it out. Home design, definitely. And here it's called Digi clock. Yeah, that's what it says. I wonder what that is. Okay, we got a direct driven. So that will be 74141s, nixie drivers, and that will be decimal counters. 7990. So that is decade counters, and then the 4 bits from each counter goes to each nixie driver, driving each of the tubes. But there's one thing here that is really, really bad, and that is the time base. So the time base is crystal based. Why on earth would you do that when the mains frequency is 50 Hertz? And it is carefully adjusted to be exactly 50 Hertz on average during a whole day. So that means every clock that is running off the mains frequency will always be perfectly stable. But if you have a crystal, there will always be a tiny little error, and that error will accumulate again and again every day. So after some weeks or months, you're going to lose or gain minutes. It's that much. No matter how much you work with this, you will see it as errors of minutes over weeks or months, depending on how good you are. So that is definitely a thing to change. But I think this error was fixed because I can see how it was cleaned up, but not perfectly cleaned up. So I think, yeah, let's just take a chance with this one. Let's put it like this so we can see what we're doing. I hope you're as ready as I am. And here is my chassis connection to Earth. Because what if there is a leak in the transformer? This is definitely looking like some old reused stuff. Probably from some tube gear, low voltage and high voltage. So I definitely want a protective chassis connection. Power is on. Nothing at all. What happened here? Oh, we got some switches here in the back. Not a lot of nothing because... Oh, bummer. But anyway, I was promised it didn't work. So I got exactly what I paid for. Perfect. Oh, that was not so lucky. So the problem is the transformer. Because I got my standard AC voltage coming in here, 225 it is today. 0 volts and 0 volts on the two outputs. So yeah, that is why nothing happens here. The transformer is broken. What do you think about that? So I took out the fried transformer, and it's definitely I mean, it's gotta be that, right? But I really don't see. So maybe this has been changed or something. But why wouldn't you clean all this up? I really want to power this up the way it is now and see what is actually going on. So let's just do that instead of cleaning anything. Let's just try and give it a little bit of high voltage and low voltage. All right. So this will be the low voltage. See, this goes to the rectifier, capacitor, regulator, another capacitor. So that will be the 5 volt. And here is the high voltage for all the nixies. So that should be possible. So let's try and see what is going on here. That was my low voltage AC input. I'm now putting in DC here. I'm just putting in 10 volts. So let's measure. All grounds on all capacitors, they're connected together to ground of everything. So this one here is just my voltmeter ground. So my input voltage is 8 volts. So I lose about 2 volts almost in the rectifier, and that is completely normal with old crappy rectifiers. Also try to swap the polarity of the AC input here, where I'm using DC at the moment, and I get the same DC voltage. So then there is a big fat 5 volt regulator here on the back, and the output of that one goes to this capacitor, and that is very close to 5 volt. So far so good. Then I take my oscilloscope and then I measure on the test point to all the dividers. I think this is halfway through the dividers. Oops. Look at that. And what do you know? 100 hertz. Very, very accurate indeed. That is a big surprise to see that many zeros. So that means this time base is amazingly accurate. And then this will be the seconds 7490 decade counter. And we can actually see through the PCB here the 4 bits. 2 there and then a little signal and then 2 more, right? So I bet the one to the right here is the one I want to be looking at on my scope. And if you see this, I mean the time is definitely running. 1, 2, 3, 4, 5 seconds, see? Time is going. So I believe all the digital low voltage stuff is working. Let's go and get some high voltage. So don't you know any other cool way to power up old nixie clock stuff than using a tube power supply from the 60s? So let's see. So that is 160 volts, and I believe it is definitely working. So that is great. I think we should roll down the blinds in here a little bit. The sun is too bright. What a lucky day. What smell is that? Oh, you can still see the all the burned and sod and whatnot is behind here. So I need to clean this up a lot better. See, they tried to clean it from the outside like that, but they didn't clean it. But it's definitely running. And here's my power consumption. 10 milliamps is my full scale current at 160 volts. And because they're directly driven, so I want to run at the lowest possible DC voltage. I really don't want this to be super bright, but I want full coverage of all the cathodes. And see what happens if I crank down the voltage a little bit. Then you're gonna get, see? Some of the digits, they're not gonna cover up completely. And this is due to too low voltage. And then you just crank it up until this happens, and then you're done. If you see, if I give it more, this is 180. Then they are very, very bright, and you don't want that. So I go back to 160 like that. All right, let's go and see if we can find a new transformer for this unit. So look what I found. I went through my old stash of nixie clock projects. So here's a power supply for a nixie clock made using a transformer. So there's a low voltage and a high voltage winding specially made for nixie clocks. And this is actually a little bit smaller compared to the other one. Is it? Yeah, it is a little bit smaller. But let's try and see if this will work. So here's my own little tiny transformer mounted. I mean, let's see if this thing works. And then turn off all this light. Ooh, we don't have enough anode voltage. What a sucker. Probably also don't have enough to run the time, so that is just too small. No. Okay, so it is up and running now with this transformer as the high voltage part. So my problem was the low voltage using way too much power, and that is because this transformer was designed for a PIC 16 and just two ICs to drive the nixies, right? Two 74141s. And if you count here, all those chips, they just use way too much power. And that is, of course, a problem. Let's just play a little bit more with this. So we've got 3 switches here in the back. The first one stops the time. And that's actually all it does. The middle one goes into high-speed mode. I guess this is a set mode. And then in this mode, the other one, where you can set how much super fast you want. Way too fast and just a little bit too fast, so you can go for the minutes, right? So here we hunt the hours. So right now it's 16:02. So then I need to go and wait all the way until... Oh, now we need to be careful, right? 16... Oh, see? Oh, stop. Fuck. And now it takes 10 minutes to figure this out again. Ha ha, that sucks. Oh, man. Do I need to say that this is not the way that I would have made a set feature? Just saying. Anyway. I think I will go and clean this up a little bit more, and then I will figure out how to make 5 volts. I really wanted to see if I could make 5 volts from this tiny little transformer. But what I could do is I could rectify this using Schottky diodes, and then I could use a switch mode step down to make my 5 volts. Then I bet I would be able to do it. I mean, that could be a way. Or I could just totally cheat and take a mains to 5 volt tiny little micro brick and put in, and then be done with that, and then use this one for the high voltage. So I got plenty of space here to solve that. But I also wanted to change the time base maybe to 50 Hertz instead of this crystal kind of stuff. But I got to admit that it's actually quite accurate, but still a tiny little bit of error will accumulate over time. So see, after a lot of cleaning, it looks really different. And here's what I did. I ended up using my own little transformer here for the high voltage part, and then for the 5 volt I put in this little switch mode module. I think it's actually almost the same as this one, but this one is a 12 volt version, but they also come in 5 volts, and they're really nice and smart to solve problems like this. And also there's a little thing, it's just against my religion not to have a fuse. What if this module short circuits, or what if this transformer is doing stuff like that? So I don't know. So a fuse, definitely. I couldn't find one of those screw the cable, hold the cable thingy, but actually this is, I don't even think this is legal to do it like this, but I just added a little bit of glue because it is actually really stiff. It's very hard to put through here, so by adding a little bit of contact glue, it's definitely not going anywhere. I can yank this and hold the entire unit, so yeah. And then I just glued the other. This transformer is just cable ties and contact glue under here. And then I cleaned all the PCB, so the rest of the smell is gone. And I've been looking a little bit on the year. Code 72 is the newest I can find. So I mean, I think this unit is from 1972. Isn't that amazing? I am really happy about the milling, both of the front and the acrylic. That is just very nice. So now I got a clock. It's still a little bit funny the way to set it and all that, but maybe I will fix that one day. But now I'll just play with it and be happy. So that concludes this video. Thank you very much, and please come again tomorrow.